Question 13. To determine the following probabilities, specify which approach seems to be the most appropriate: theoretical, experimental, or subjective. Explain your answer. The probability of winning a lottery prize, like the 649, well, we can calculate that exactly. That is theoretical. It's mathematical. B, the probability of being a victim of a criminal act. This one, it's kind of up in the air. You're going to have to take a lot of things into account, like where you live. Is there a lot of crime in your neighborhood? If so, then your probability of being a victim of a criminal act goes up. Do you know Kung Fu? Do you carry a baseball bat around with you? If so, the probability of you being the victim of a criminal act goes down. If you live out in the middle of nowhere with no people around, the problem of being a victim of a criminal act really depends on your circumstances. But you're not going to work that out theoretically. You're going to work that out by looking at data. If you're looking at the population of Canada and how many victims of crimes there are, you can actually count this and you can calculate the odds of a random Canadian being the victim of a criminal act. That's experimental because we can look at the statistical data and we can work it out. C, the probability of a thumbtack falling on a person's head. This is ambiguously worded. Is the person just walking down the street? Then the probability is like 0 because there are no thumbtacks falling from the sky. Maybe there are, but I think your odds of getting hit by lightning are higher. It really depends. Are you in a room where you are the person throwing the thumbtack up into the air and seeing if it lands on your head? In which case, your probability of getting hit on the head with a thumbtack goes up a lot. This can be subjective. If you're just talking about people's opinions, it's very low. So yeah, that tends to be subjective. But if you're talking about that there is a thumbtack, if you're standing in a room of a certain size and you throw the thumbtack straight up, what are the odds of it landing on your head? You can calculate it because you know the surface area of your head. You know the surface area of where the thumbtack is being dropped from. You can work out an actual mathematical probability of that. But if you're just talking about randomly walking down the street and having a thumbtack fall on your head, it's very subjective at that point. Subjective, I'd say. But you could also say experimental if you're talking about within a closed system, within a closed room, and somebody's actually throwing a thumbtack in the air. You could look at, you're throwing a whole bunch of thumbtacks in the air and you see how many hit somebody in the head within a closed room, closed system. But mathematical, it could be theoretical because you could look at the thumbtack is being dropped in a random point. This person is taking up this much room with their head. What's the mathematical probability of it landing on their head? Like imagine this rectangle is the room and this is the size of the person's head. The thumbtack is being dropped randomly within this area. Then you can calculate the actual probability of a thumbtack hitting this person in the head. It really depends on the experiment. And since this is kind of ambiguously worded, we don't know whether they're talking about subjective, experimental, or theoretical. So you could answer all three to these. D, the probability of obtaining tails after tossing a coin. If it's a fair coin, it is going to be heads or it's going to be tails, and 50% of the time it's going to be heads. There's only two outcomes, and they're equally likely. The probability of getting tails is 1 out of the 2 possible outcomes, 1 out of 2. And that is theoretical. That's a mathematical probability. It's totally theoretical. Not subjective, not experimental. I mean, you could do an experiment. If you do this 1 billion times, close to 500 million times, it's going to be heads, and 500 million times it's going to be tails. Law of large numbers. As you do this experiment over and over again, the experimental probability gets closer and closer to the theoretical probability. It's definitely theoretical. E, the probability of finding a 4-leaf clover. 4-leaf clovers happen in nature at a certain rate that can be predicted. All you would have to do is you'd have to go through a field, let's say 1 billion clovers, count how many 4-leaf clovers you have, and that would be an experimental probability. Experimental. And that is it for question number 13. Have a good day.